Hi everyone. So I'm going to be covering section 2.3 in this video, and this is lesson 2. So we're going to be dealing with multi-step equations that have fractions. I'm going to show you 2 strategies for how to handle those fractions. Go ahead and have your notebook ready, and let's just dive right into some examples. So go ahead and take a moment to copy this in your notes. I'm going to call this method 1, where we work with the fractions throughout. So when I'm looking at this equation, I'm keeping those steps in the back of my mind that I had talked about previously. I don't see parentheses, so I don't need to distribute, but I do see some like terms on the right-hand side. I have a 1/4 v and a 5/2 v. Now, in order to combine these 2 fractions, we need them to have the same denominator. So hopefully you can do 2 and 4 quite easily. The smallest thing that they can both create through multiplication is 4. This fraction already has a 4, which means I want to make the second fraction have a denominator of 4 by multiplying by 2. And if I do that to the bottom, I got to do that to the top. So this is going to make this, instead of a negative 5/2, it's going to make it, let me just rewrite everything here, a 10/4 v. And now I can add these 2 fractions together. So this is going to give me negative 11/2 equals 1 plus 10 gives me 11. Denominator stays the same, and it's got a v attached to it. This fraction is being multiplied with the variable v. So in order to do the inverse of multiplying, which is to divide, you might recall that when we divide by a fraction, we end up doing keep, change, flip, where we end up multiplying by the reciprocal. So that's what I'm going to do to get this variable alone. The 11s cross cancel and the 4s cross cancel, leaving me with my variable v. What I do to one side, I must do to the other. So I got to multiply the left side by 4/11 as well. And I can also cross cancel the 11s here. They're diagonally across from each other. They turn into 1s. I can't cross cancel the 2 and the 4, but I can reduce them. I always like to reduce this way first before I multiply, simply because 11, 2, and 4, those are all really nice small numbers, but if I had multiplied at first, I would have gotten 44 and 22. That's a little bit harder to reduce. So I'm going to reduce both of these numbers right now by dividing each one by 2. 2 divided by 2 is going to give me a 1. 4 divided by 2 gives me a 2. So now I can multiply. 2 times 1 gives me 2. 1 times 1 gives me 1. Positive times negative gives me negative. So I can leave my answer like this, or I can simply write it as an integer. So here's the answer that we're getting. So that's one strategy that we can use to work with fractions, is just to work with fractions with what we currently know throughout. Let's take a look at another method that you might find very helpful. And we actually learned this method in some previous lessons already. I sometimes refer to this as clearing the fractions. Some of your other teachers might not call it that, but it's kind of what we're doing here. The first thing that we want to do is find the LCD, or the least common denominator, of all fractions in the problem. So sometimes that's 2 fractions, or sometimes it's 3 fractions or more. And then step 2, we multiply all values in the equation by the least common denominator. And what ends up happening is that the denominators will all turn into 1s, and they'll either cross cancel that LCD or cross reduce it to something smaller. So here it looks like I have 3 different fractions. Whoops, that's a marker. I want a highlighter. Do I not have one? I'll just use the pen. So it looks like I've got 3 different denominators, but 2 of them are exactly the same. So really I'm just looking at denominators 2 and 4. Well, we just found the least common denominator for those 2 numbers on the previous slide, and that's going to be 4, not 2. It's going to be 4. And I'm going to take this 4 and multiply it to every single value in the equation. When you do this, remember, you're only doing it to the tops. We used this strategy for two-step equations. And all of my denominators are going to turn into 1s, and they're going to divide into the LCD to either cross-cancel it or reduce it. 4 divided by 2 is going to leave me with 2. Now to get my new integer value, which is what I should have when I'm clearing these fractions, I simply multiply with whatever is left. 2 times 11 gives me 22. Don't forget, it's negative. These 4s are matching. They're going to cross-reduce completely and leave you with nothing but 1s. In my numerator, I've got 1 times 1, which is just 1, and there's a variable. So notice as I'm doing this, I'm not putting all of these over 1. The benefit to doing this strategy is that everything turns into an integer. I'm going to bring down my plus. The 2 reduces the 4 into a 2 again, just like the first value. 5 times 2 gives me 10, and there's a variable attached. So visually, this might just look a little easier for you. So if you want to use the first strategy, go for it. If you want to clear the fractions like this, go for it. 1v plus 10v gives me 11v. I'm going to divide both sides by 11 since this is now a one step that has multiplication. V is now alone. 22 divided by 11 is 2, and I should get a negative. So we end up getting the same exact thing. So regardless of which method we use, we get the same answer. So just like in the previous lesson, I showed you guys how to check your answer. I'm going to show you guys how to do checks here as well. So let's take a moment to check our answer. We got that V was equal to negative 2. So keep in mind, again, when you're doing a check, you're not solving. You're replacing all of the variables with the answer you think you got, and then you're evaluating using order of operations. So everywhere I see a V, I'm going to put a negative 2. Be really careful when you do this here. These V's are being multiplied to these fractions. So I'm actually going to make my integer answer look like a fraction by making it a negative 2 over 1. So I'm going to start substituting. This value on the left stays the same. And instead of 1/4 times V, it's going to be 1/4 times negative 2 over 1 plus 5/2 times negative 2 over 1. Now, order of operations. Hopefully at some point you guys have learned order of operations. We sometimes use an acronym to describe it. We call it PEMDAS. I do parentheses first, which I don't see any parentheses here. The E stands for exponents, which I don't have any here. I need to multiply, which is what this M stands for, before I add or subtract. And of course, hopefully you know the D stands for division. So I'm going to multiply these two values here. That stays the same. I'm going to use cross-reducing as a way to simplify this first. 2 divided by 2 gives me 1. 4 divided by 2, gives me 2. 1 times 1 gives me 1. 2 times 2 gives me 2, and it's a negative. I'll do the same thing over here. So I'm just going to bring down my plus sign because I can't add yet if I still have to multiply. The 2's will completely cross-cancel, turning into 1's, and I get negative 5 over 1. And the last thing that I need to do is I need to combine these two fractions. So when we add and subtract fractions, again, we need them to have the same denominator. The nice thing about 2 and 1 can become any number we want. We just need to multiply it by 2. So this becomes negative 11/2 equals negative 1/2 plus negative 10 over 2. And now the last thing I need to do is just add these two fractions to see if it matches the number on the left. So my number on the left is going to remain a negative 11/2. Two negative signs are the same, so I add. 1 plus 2 gives me 11. The 2 stays the same. I get the same value on both sides, so this is the correct solution. Let's try another one. This one is a little more complicated. simply because I've got parentheses here. So regardless of which method you use, if you see parentheses, you must distribute first, regardless if you're clearing fractions or working with them. I encourage you when you distribute to do that work off to the side if you're dealing with numbers that look like this. Remember, when we distribute, we're taking the number touching the parentheses and multiplying it to each of the inside terms. So I'm going to do negative 18 fifths times 10 thirds. I can cross reduce a couple of things here. The 5 and the 10 can both be divided by 5, giving me 1 and 2 respectively. The 3 and the 18 can also be reduced. If I divide both by 3, I get 1 and 6. And that's all I can cross reduce. So I'm going to get negative times positive gives me negative. 6 times 2 gives me 12. 1 times 1 gives me 1. So I get a negative, so this is also the same thing as just an integer, a negative 12a. Careful not to drop that variable. I'm going to do the same thing if I multiply negative 18 fifths with the negative 7 halves. Careful, this minus sign does actually count as a negative in front of that fraction. And I've got a few things I can cross reduce here as well. 5 and 7 won't reduce, but I can reduce 2 and 18. They're both even numbers, so I can divide them both by 2, giving me 1 and 9. And now I can multiply. Negative times negative is going to give me a positive. 9 times 7 is going to give me 63. 5 times 1 gives me 5. So since it's a positive, I'll need to write that this is plus 63 over 5. And I just bring down my equal 51. So at this point, you can solve it like a typical two-step, since I've got two operations happening with my variable, and work with the fraction throughout. Or you can clear the fractions. Since that method might still be a little new for some of you, I'm going to use that strategy here. It actually works out quite easily because my LCD for this problem is just going to be the one denominator that I see in the equation, which is 5. So I'm going to take that LCD and multiply it to every single value in my equation. 5 times negative 12 is going to give me negative 60. Don't forget your variable. The 5s here for the fraction are going to completely cross reduce, leaving me with 1s. 63 times 1 is just going to give me a plus 63. And then 51 times 5, you might want to do that off to the side. 5 times 1 is 5. 5 times 5 is 25. So I get 255. And now it's a two-step. I'm going to subtract this 63 first. Remember, we want to add or subtract our constant first. And that's going to give me 2. I have to borrow here to make this a 15. So that's going to give me 9. 1 minus nothing gives me 1. And I bring down my negative 60a. My last step is to divide both sides by 60. And now the challenging part, since these numbers are a little big, I want to reduce this. So when I look at both of these numbers, 192 and 60, even though they look intimidating because of how large they are, notice how both of them are even. At the very least, I can start by dividing both of these values by 2. So 60, I can do that in my head. That's going to give me negative 30. 192 divided by 2, I might need to do a little bit of work. 2 goes into 19 9 times, giving me a difference of 1. I bring down my 2. That's a 12. 12 divided by 2 is 6. So I get 96. They're both still even, so I could divide them by 2, but I'm actually looking at these and thinking of a number that's a little bit bigger. 30 is a nice multiple of 3, and 96, if I add both of those numbers up, 9 plus 6 gives me 15, which is divisible by 3, so is 96. So I'm going to divide both of these by 3 to see what I get. That's going to give me 30 2 divided by negative 10. They're both still even, so I know I can divide both of them by 2. So that's going to give me negative 5 for my denominator. 32 divided by 2 is going to give me 16. And then here is our final answer, which I don't believe reduces any further. Okay, so a little bit of a challenging problem. Fraction problems do take quite some time, but the more you do them, the easier they get with practice. Let's go ahead and check that answer. So our answer was 16 over negative 5. So let me go ahead and erase my board. A equaled negative 16 over 5. And I'm going to do it the exact same way. I'm not going to distribute just yet. First, I'm going to substitute where I see the variable. And again, this is getting multiplied here. So this is 10/3 times negative 16/5. Minus 7/2 is equal to 51. So assuming we got the right answer, after we do all of these operations with the fractions, it should simplify to a nice integer. Okay, so going back to order of operations, which is PEMDAS, I want to do everything in this set of parentheses first, and I have to multiply before I subtract. I can reduce the 10 and the 5 by reducing them by 5s. This will give me 1 and 2. So I'm going to multiply those to give me a negative 32 over 3. Now you might be wondering, why am I not just distributing this number outside here? When you can avoid the distributive property and just work with what's in the parentheses first, it's highly encouraged that you do that. It makes the problem a little bit easier. So I'm going to keep going here and subtract the 7/2. And in order to add or subtract fractions, we need the same denominator. You can list your multiples out for 3 and 2, but hopefully you know at this point that the smallest number 2 and 3 can both make through multiplication is 6. I'm going to have to multiply this first fraction by 2 and the second one by 3. So that's going to give me equivalent fractions of negative 64 over 6 minus 21 over 6. And before I multiply with this 18 over 5, again, I'm going to get this value in the parentheses down to one number so I don't have to use the distributive property. Their signs are the same, so I'm going to combine them. 64 plus 21 is going to give me 85, and it should be a negative 85. Denominator stays the same. And now I'm going to look for things to cross cancel and cross reduce. Let me see if I can move some of this stuff. I'm going to move this over here. Okay, so 5 can evenly go into 85. Let's see, that's going to give me 5's going to go into 8 once with 3 left over. Bring down my 5. That's going to go in 7 times with nothing left over. So this will give me a 17. And then 6 will go evenly into 18 3 times. So my denominator is giving me a 1 here. So I know that whatever I get on the left-hand side, I can write it as an integer. I don't have to put it over 1. To figure out what that integer is, negative times negative will give me positive. 3 times 17 will give me 7 times 3 is 21, carry the 2. 3 times 1 is 3 plus 2 more is indeed 51 on the left. So we got the same answer. That means that this is a valid solution. Okay, let's try one more. Again, I know these are probably pretty challenging at this point in the game, but if you take your time and you just go through all of the steps in order, fraction problems will get easier. You'll get stronger in that skill. So here I've got some parentheses and I've got a term outside the parentheses. We want to distribute first and then look for places where we can combine like terms. So I'm going to distribute this -7/2 into the two values in the parentheses and only those two values. The p's outside so we don't distribute. And just like last time, I'm going to do that off to the side. -7/2 times -8/3. 2 and 8 can reduce. I can divide them both by 2 and get 1 and 4. 3 and 7 won't reduce, so I don't need to check that. Negative times negative will give me a positive. 7 times 4 gives me 28. 1 times 3 gives me 3. And there's a variable p attached to this term. I'm going to distribute the -7/2 with the negative, don't forget it's a negative, 7/3. 7 won't reduce with 2 or 3, and since the other top number is also a 7, there's no need to check if it reduces anywhere. So that means I can just multiply and I should get a fully reduced fraction. Again, negative times negative will give me a positive. 7 times 7 will give me 49. 2 times 3 will give me 6. So I get a positive 49/6. And then I just bring down my plus p. Now, again, you might want to work with the fractions throughout. That's your prerogative. I think I might try to cancel these out. I might try to clear my fractions. I only have two denominators, 3 and 6. So the smallest number they can make through multiplication is 6. So I'm going to multiply everything in this problem by 6. Now, sometimes this technique makes the numbers a little harder to work with, so you might want to just try and work with the fractions. Sometimes it simplifies things really nicely. And notice I'm multiplying even the integer values by 6. You do it to every single value in the equation. 34 times 6, I'll have to do that off to the side real quick. 6 times 4 gives me 24. 6 times 3 is 18, plus 2 more is 20. So we get 204. 3 can reduce with 6 and make it a 2. Remember, all these denominators are going to turn into 1s. 28 times 2. If you can't do that in your head, do it off to the side. 8 times 2 is 16. Carry the 1. 2 times 2 is 4, plus 1 more is 5. So I get 56p plus these 6's completely cross-cancel, leaving me with 49. 6 times p just gives me 6p. And even though the numbers are a little bit bigger, this is at least a little bit easier for me, at least, to work with than all these fractions up here. I've got two variable terms that I can combine. 56 plus 6 more is going to give me 62. Don't forget, it's got a variable attached. And now I'm going to solve the two-step. I need to undo this constant first by subtracting. These are going to go away. I can't do 4 minus 9, and I can't borrow from the 0, so I need to borrow from the 1, make this a 10, borrow from the 10, make this 14. 14 minus 9 is going to give me, that's going to give me 5, right? 9, 10, 11, 12, 13, 14. Yeah, okay. And then 9 minus 4 gives me 5, and 1 minus nothing is 1. I'm going to bring down my equals 62p. And last step is to multiply or divide by the coefficient. Here, this number is touching, which means multiplication, so we want to divide. Okay, so this might be a little tricky to reduce. I may have to sit and think about this for a second. 155 is not even, so unfortunately I can't divide by 2. 1 plus 5 is 6. 6 plus 5 is 11, so that's not divisible by 3, so I can't divide by 3. Does this reduce? It's not divisible by 5 either. The top number is, but not the bottom. Let's see, will 7 work? 7's not going to work either. What'll go into 62 and 155? I'm convinced that it can reduce. Let's play around with some numbers for a second. I'm going to break this down into its multiples and see what I get. So I can break this down into 2 and 31. And 31 is prime. So that means that I could try 31, since I know 2 won't work. Let's try that. So I'm going to do some guess and check to see what I would multiply with 31 to get 155. Let's try 5, because I want my number to end in a 5. So even I have to think about these problems a little bit sometimes. So don't feel like you're, not doing really well with these if it takes you a little bit of time. 5 times 1 gives me 5, and 5 times 3 gives me 15. There it is. So 31 is what I want to divide both of these numbers by. We got it. Not a very common number to reduce fractions with. This one was pretty tough. The top number, if I divide it by 31, should give me a 5, since that's what we just found out we would get. And then 31, if I divide 62 by 31, you could probably look at it and see that you would multiply it with a 2. 2 times 1 gives me 2, and 2 times 3 gives me 6. So I end up getting 5 halves here. Whew. What a whopper of a problem. All right, let's check that answer, and then we'll call it a day with this lesson here. So P equaled 5 halves. I'm going to substitute here. Times 5 halves. Whoops. Minus 7/3, close parentheses, plus 5 halves. I'm going to multiply first. I can cross reduce the 2 and the 8. The 2 turns into a 1 and the 8 turns into a 4. So this is going to give me negative 20 over 3 minus 7/3, close parentheses, plus 5 halves. Never drop the parentheses inadvertently. Always keep the parentheses throughout until you're convinced that it's safe to drop them. Otherwise, you're changing the order of operations. My denominator is already the same here, thank goodness, so I can just subtract the values, or in other words, I'm actually going to add them here because their signs are the same. So we get negative 27/3 plus 5 halves. I'm going to multiply here. This can actually reduce. 27 divided by 3, that's going to give me 1 and 9. So now I'm just going to multiply. Negative times negative gives me positive. 7 times 9 gives me 63. 2 times 1 is 2. Plus 5 halves. Again, my denominators are the same, so that was at least kind of easy for this problem. So I can just add these numerators to get 68. And then if I divide 68 by 2, I'm just cutting that number in half, which I can easily do with both of those values. 6 divided by 2 is going to give me 3, and 8 divided by 2 gives me 4. So this ends up being the correct answer. So a bit of a challenging lesson for you guys today. I'm going to pause the video here and let you guys give these a try. And then when we unpause, you should see the solutions. Okay, so here are the solutions that I was getting. Since we're going over them together, I didn't do a check. But I encourage you to do a check if you feel like you're not getting the correct answer to see if it's working out. So for the first one, For both of these, actually, I cleared the fractions. If you didn't clear the fractions, that's fine. We should still be matching. The least common denominator for the first one, if you are using that method, is actually 12. So you want to multiply everything in the equation by 12, and you'll get this as your integer equation. Then I combined my like terms to get 51 and divided both sides by 51. I kind of ran into the same issue as before, where I was convinced that it could reduce because just looking at this, I can't see any reason why it would stay such large numbers. So what I did, I used the same strategy as before. I took the 34 and broke it down into its factors. I kind of did like a little factor tree, and I divided by 2 first and found that if I multiply by 17, that gives me 34. So then I said, well, 17 is prime. So I'm wondering if 17 will go into 51. And it does. If you multiply it by 3, you get 51. So 17 is the common number that you want to divide both these by. If you divide 34 by 17, it should leave you with a 2. And then if you divide 51 by 17, you should get a 3. So you should get negative 2/3 here. A little bit of a challenge when you get to the reducing step for this one, but not too bad. The second one, you've got to distribute first, regardless of what method you use. I did a little bit of work off to the side to show you that. Negative 10/3 times 3 over 1, I just made it a fraction. The 3 is cross-canceled completely, leaving me with a denominator of 1, so I wrote it as a nice negative integer. Don't forget your variable k. Negative 10/3 times negative 3/2. The 3 is completely cross-canceled, becoming 1s. The 2 became a 1 and reduced the 10 to a 5. So again, I got an integer, but don't forget that 2 negatives leave you with a positive. I cleared the fractions here since I only had the one denominator. I multiplied everything by 3. The 3's canceled here, giving me 95. 3 times negative 10 gives me negative 30. 3 times 5 gives me 15. And from that point, it's a typical two-step. Subtract the constant first to get 80. Divide by the coefficient to get negative 80 divided by 30. And then these numbers both end in 0, so I can divide them both by 10. So here's my final answer. I hope that you found these examples helpful, and good luck with everything.